your instructions. In general, you just need to follow the PowerPoint. On some of the slides, there are instructions for you in the yellow boxes. Please make sure the sound is turned up on your device so you can hear the narration. And remember, if a slide asks for homework, don't forget to send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given.
By the end of this lesson, you should be able to define the term specific heat capacity, and you should be able to apply the idea of specific heat capacity to choosing materials for different purposes. Now, we've already looked at something called specific latent heat. We're going to move on now to look at something called specific heat capacity. Now, the two things sound quite similar, but they are actually very different. So it's important that we can tell the difference and be absolutely sure that we know which one we're referring to. Let's start by looking back at our work on specific latent heat. If you remember, we drew what we called a heating graph. And this is what happens when you take a material and start adding energy and heating it. First of all, the temperature rises, and then at a certain point the material, even though you're still putting energy in, still heating it, the temperature stops rising. Now that is when it is melting and the energy you're putting in is being used to break bonds. If you carry on heating it, the temperature continues to rise until again you get this little straight section, a little flat section, and again here there's another change of state and the energy you're putting in is being used to break the attractions between molecules or atoms. Now, specific latent heat refers really to these flat sections. Latent means hidden, and we use that term because it's not easy to see where that energy that you're putting in is going, but you know now that it's being used to break the attractions between molecules. So latent heat refers to this section and this section. Now, in this lesson, we're going to look at instances where the temperature continues to rise. But before we do that, let's remind ourselves of our definition of specific latent heat. Definition of specific latent heat. The specific latent heat of a substance is the amount of energy required to change the state of 1 kilogram of that substance with no change in temperature. Now we're going to think about specific heat capacity, which is the topic for this lesson. Start with this activity. If you think to a sunny day on the beach, by the end of the day, you often notice that the sand has become really quite hot, sometimes too hot almost to walk on, but the water has stayed cool. Why do you think this is? Stop the recording here and see if you can come up with an answer. Well, it's a difficult question to answer, but some points that you should bear in mind. The Earth, different parts of the Earth, are all about the same distance from the sun, which is where we're getting our energy from. So roughly the same amount of energy falls on all parts of the Earth that are facing the sun. So the same amount of energy is falling on the water as is falling on the sand. So why then is the sand getting really hot and the water staying cool? Well, the answer refers to something called heat capacity. Different materials have a different property called heat capacity. Putting the same amount of heat into some materials makes their temperature rise more than in other materials. And in our case, the sand has a small heat capacity, so it starts to rise in temperature quite quickly, whereas water has a very large heat capacity. It will take the same amount of energy and the temperature will only rise a very small amount. So that is heat capacity. We can use the same idea to explain this phenomenon. If you bite into a McDonald's fruit pie, the outside can be relatively cool and the inside can be boiling hot. It's because the inside, which is quite liquid, has a much higher capacity for storing energy than the outside, which is pastry and doesn't contain a lot of water. Now, we've been talking about heat capacity, but the amount of heat energy that something will contain depends also on how much of that material you have. So in order that we're all talking about the same thing, we have a standard definition. The standard definition of specific heat capacity is the specific heat capacity of a material is the amount of energy needed to raise the temperature of 1 kilogram of a material by 1 degree centigrade. So now we have a standard definition so we can compare different materials, because we know that if we're comparing specific heat capacity, we're always talking about 1 kilogram of that material. Now, scientists have measured the specific heat capacity for lots of materials. And here are a couple of examples. Concrete has a specific heat capacity of 850 joules. That means if you take a block of concrete, 1 kilogram in mass, and put in 850 joules of energy, you will raise the temperature by 1 degree centigrade. Oil has a much higher specific heat capacity. To raise the temperature of 1 kilogram of oil by 1 degree, you would need 2,100 joules of energy. And water has a very, very high specific heat capacity. To raise the temperature of 1 kilogram of water by 1 degree centigrade, you would need 4,200 joules. So water can absorb lots and lots of energy without the temperature rising very much at all. And that's important for lots of reasons, including the fact that it helps regulate the temperature of the Earth. As the sun's energy falls on the Earth, the majority of the surface of the Earth is covered in water, and it can absorb lots of that energy without the temperature of the Earth rising quickly. Now, we should note that the reverse is also true. Something which can absorb a lot of energy can release that energy slowly. So when the Earth gets cooler, heat energy from the oceans is released back to the cooler land and air. We use the idea that different materials have different specific heat capacities to help us choose materials for specific purposes. A high value of specific heat capacity means that the material can store a large amount of heat energy for a small temperature change. So for example, if you have electric storage heaters, they often have lumps of concrete in them. During the night, when electricity is cheap, electricity is used to heat those lumps of concrete and store that energy. However, the temperature of the concrete doesn't rise a great deal because it has a high specific heat capacity. During the day then, when the energy is needed, the energy stored in those concrete blocks can be released back to your room to warm it. This is also the reason why we use water in lots of applications. Because water has a very high specific heat capacity, it can carry lots of energy. So we use it in systems like radiators and also in your car's cooling system, where it carries the heat of the engine away to the radiator to cool it. Now here's a question for you. Using the idea of specific heat capacity, explain what material you would use to make the body and the handle of a saucepan and why. Answer in your book, please. Your final task from this lesson is to take a picture of your work and send it to Mr. Rahman via Show My Homework by the 5th of June, which is Friday. Thank you.